Hello to all, welcome to Magic Tutorials for Chemistry. So I started my channel with the P block elements, grade 12, chapter number 7 of volume 1. So last week we were doing with group number 15 elements. So today we'll start with group number 16 elements. The entire P block chapter, it is a concept based chapter where the atomic radius decreases or increases, ionization enthalpy increases or decreases. So it is completely a concept based where you have to understand why it is increasing or decreasing. The reason you should know. Correct. So let's begin with group number 16 elements. So group number 16 elements, they are oxygen, sulfur, selenium, tellurium and polonium. Correct. I remember it as Os, Sete, Po, and its electronic configuration in the noble gas configuration, if we write helium, neon, argon, krypton, xenon, radon. Correct, in the order. So oxygen, the atomic number is 8. I'll write here the atomic number 8. Sulfur, the atomic number is 16. Correct. How do you write the atomic numbers? If you know the atomic number of the first element, it is easy for you to write the atomic numbers of the other elements of the group. How can you write that? So first over here you need to add 8. So that becomes 16. Correct. After that you need to add 18. If you add 16 plus 18, the atomic number will be 34. Again to 34 you add 18, it becomes 54, 52, correct, and to 52 if you add 32, it becomes 84. Hope you remember this K element shells we were studying, 8, 18, 18, 32, electrons can be accommodated, right. So based on that only you can write the atomic number. So we have written here the atomic numbers. So you can check here 8, 16, 34, 52, 84. Atomic numbers of the elements of group number 16, and I have written the electronic configuration also. And we know down the group what is happening, one shell is added. Correct. So one shell is added as we move down the group. You can see here 2s2, 2p4. Next will be 3s2, 3p4. The next will be 4s2, 4p4. 5s2, 5p4, 6s2, 6p4. Correct. So you can see the numbers, the valence shell you can see 2, 3, 4, 5, 6. One shell is added as we move down the group. Now all these elements or group number 16 elements, they are called as oxygen family. It can be called as an oxygen family because the first member is oxygen. It can also be called as chalcogens. Chalcogens, which is a Greek word that means ore forming. Chalcos, that is ore forming. Now how are they forming the ores? That is copper ore, if we see, then copper will be in the combined state with oxygen. Correct. The ore of copper with oxygen, it becomes the oxide form. The ore of copper with the sulfur, it becomes a sulfide form. Got it? So we can also say these elements, they can be called as chalcogens. It's a Greek word, chalcos, that means ore forming. Just make a note of these points, then we will move further to the properties. Yes, so oxygen, we will see the properties now one by one. So the first property, what is the character? So oxygen, it is a non-metal. Oxygen and sulfur, they both are non-metals. Selenium and tellurium, they are metalloids. And polonium, it is a radioactive metal. It is also a metal, it is radioactive metal. And its half-life is 13.8 days. half-life, 13.8 days. Now what is this half-life? Time taken by half of the atoms to decay. Okay, that is 13.8 days half-life. So oxygen and sulfur, they are non-metals. Selenium, tellurium, they are metalloids. Polonium, it is a metal, radioactive in nature. 13.8 days is the half-life. So down the group you can say we can see that we are moving towards the metal. Correct. Now let's see the character. So oxygen, it is a gas. It exists in the gaseous form. Oxygen exists in the gaseous form. And it also exists in the diatomic form. We know that it is O2, diatomic form. The rest of the elements, they are solids. We know we are coming down towards the metal, it is a solid. And they exist as octaatomic. They exist as octaatomic. And that is S8. Correct? So down the group, octaatomic, on the top O2, diatomic molecule. Let's check the allotropes of oxygen. Hope you have copied the electronic configuration. So I'll just remove it. Yes, so allotropic of oxygen and sulfur. Oxygen exists in two allotropic forms, that is O2 dioxygen and ozone, O3, ozone. Correct? There are two allotropic forms of oxygen. For sulfur there are two forms, that is rhombic and monoclinic. So this is about the allotropic forms of oxygen and sulfur. So let's check for the atomic and ionic radii. So we have started with the properties now. So down the group we will discuss, because we are studying the group elements. So atomic and ionic radii, generally what happens, it increases down the group. Generally if we speak, the atomic radii or the size of the atom, volume of the atom increases down the group. Same here in group number 16 also. Why? Because number of shells are also added. Correct? We have seen in the electronic configuration. So atomic number is increasing. Number of protons, electrons are increasing. Number of shells are also increasing. So what will happen to the size of the atom? It goes on increasing. So the size of the atom, atomic radii, atomic volume increases down the group. Check for the next property. Yeah, we'll also do the comparison for this group number 15 and group number 16. So as we move from left to right in a periodic table, left to right, what is happening? The size of the atom goes on decreasing. Correct? The size goes on decreasing. In a period we are talking in a row. Why is it so? Because the atomic number is increasing. Correct? Right, left to right also atomic number is increasing. But number of protons increases 1, 1, 1. Number of electrons are also increasing. Protons are present inside the nucleus. Electrons are present in the orbits. Correct? So the force of attraction will be more. Correct? As the number of protons are increasing, number of electrons are increasing. So the force of attraction will be strong, will be more. And therefore, the nucleus will try to pull the electrons towards itself, force of attraction. So, the nucleus will try to pull the electrons towards itself. So what happens? The atom size goes on decreasing, or we can write the atom shrinks. So left to right, in a period or in a row, the atomic radii or the ionic radii, it goes on decreasing. So we are comparing with group 15 and group 16. So group 15 elements, the atomic radii is bigger than group 16 elements. What is the reason? Force of attraction is more. See the next property, ionization enthalpy. So we will discuss the properties and then we will also compare it with group 15 because already we have completed that topics. So ionization enthalpy, that means the energy required to remove an electron. Correct, that is enthalpy, ionization enthalpy. So let's check now. So we'll check for directly, we will do the comparison, group 15 and group 16. So group 15, the first element, that is nitrogen. We were writing the electronic configuration, helium configuration, that is 2s2, 2p3. Correct? Same way, group 16, the first element, that is oxygen, helium configuration, 2s2, 2p4. Correct? Same note, 2s2, 2p3, 2s2, 2p4. As we are moving from left to right in a period, what is happening? 1 proton, 1 electron is added. 3, here it is 4, 1, 1 it is added. So write the electronic in the orbital form. So this is 2s, this is p3, so 1, 2, 3. Next one, 2s, and for the p orbital, 1, 2, 3, 4, that is 2p. Now we know that half filled orbitals, p can accommodate how many electrons? 6 electrons. So here it is half filled. So if an orbital is half filled or fully filled, then it is always stable. It is stable. So in case of nitrogen, you can see that the p orbital, it is half filled. Half filled and it is stable. But in case of oxygen, the p orbital, it is not half filled, neither fully filled, right? So it is unstable. So one electron can be removed from the p orbital very easily in case of group number 16, that is from oxygen. Correct? Because it is not a stable configuration. So one electron from here, it can be easily removed. But here it is difficult to remove. Why? Because it's a stable configuration. Correct? So oxygen's ionization enthalpy will be less than nitrogen. So we can write it as the ionization enthalpy, that is the first ionization enthalpy of group number 15. Group number 15 is more than the first ionization enthalpy of group number 16. We are talking of first ionization enthalpy. Correct? Why? Because in group 15, that is in case of nitrogen or any element you take, the p orbital, it is half filled, stable. So more energy is required to remove an electron from the p orbital in case of nitrogen. So more energy is required. So ionization enthalpy will be more for 15th group than 16th group. Now compare the second ionization enthalpy. Compare the second ionization enthalpy. Now if suppose one electron is removed from here, okay, one electron is removed from here also. I am just drawing the p orbital. Correct? With less energy, one electron is removed from oxygen. With more energy, one electron is removed from nitrogen. Okay, first ionization enthalpy. Now one electron is removed, so now the configuration, see, p orbital. In oxygen it becomes stable. After removal of one electron from p orbital in case of oxygen, now it becomes stable. Why it is? Because it is half filled. P can accommodate 6 electrons, it is having 3 electrons, so it is half filled. But here only 2 are there. So now easily it is not half filled, not fully filled. So easily you can remove one electron from here. Correct? Because it is unstable. So what I will write is the second ionization enthalpy of group 15 is less than the second ionization enthalpy of group 16 because of the stable configurations. Correct? For 15th group, less energy is required while removing the second electron because the p orbital, it is unstable. Correct? It is neither fully filled nor half filled. But here it is stable configuration. So here now in the second electron removal time, more energy is required. So second ionization enthalpy for group 16 will be more than the second ionization enthalpy of group number 15. Just make a note of this with the electronic configurations. Okay, now if we talk of only group number 16, correct, because we are learning group 16 elements, down the group comparison we have done. Now down the group, what will happen? The ionization enthalpy will increase or decrease? Atomic size is increasing, correct? From oxygen we are coming down the group. So what is happening? The size small, big, 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 correct? So the last electron, it is loosely bound to the nucleus in case of the last element, loosely bound, or just one word you write, force of attraction decreases down the group. Why? Because the size increases down the group. Why the force of attraction is decreasing? Because the electrons are very far from each other. Correct? So size is also increasing. So the nuclear force of attraction is not there. Correct? It is less. So easily you can remove an electron. So the ionization enthalpy down the group, it goes on decreasing. Less energy is required to remove an electron as you move down the group. But in case of oxygen, more energy is required. Why? Because the electrons are strongly attracted towards the nucleus. Okay. So just make a note of this, whether it increases or decreases. We'll move to the next topic. So let's talk of the electronegativity. So down the group as we move, we are moving towards the metal, correct? Polonium, that is a metal, and metals will be electropositive in nature. They lose electrons and become electropositive. But oxygen, it is a non-metal, it will gain electrons and become negative ion, right? So down the group, what will happen? Electronegativity goes on decreasing. Correct? Seeing the character itself, you can say down the group electronegativity decreases. And remember, oxygen in the entire periodic table, oxygen is the second electronegative element. Second most electronegative element in the entire periodic table. Its value is 3.5. The electronegativity value is 3.5. Okay? And the most electronegative element in the entire periodic table, that is fluorine, the next group element, right? That also we will study. Fluorine, its electronegative value is 4.04. So So the most electronegative element in the entire periodic table is fluorine. It has a value of 4. And the second one is 3.5 value, that is for oxygen. Most electronegative element. So electronegativity decreases down the group because we are moving towards the metal. Check for the next property. Electron gain enthalpy. That means we can also write this as EGE, electron gain enthalpy. What is it? So the energy, change in energy when an electron is added to an atom. Some change will be there, no? Something is added, something is removed, changes will be there. So EGE means change in the energy when an electron is added to an atom. So let's check this. We'll take the first element, that is oxygen, and the last element I will just take it as tellurium. Okay. Compare the size of oxygen and tellurium. So oxygen, the size is small, and tellurium, the size is big. Correct, no? Down the group atomic size increases. Now what is EGE? Adding an electron. Energy change while adding an electron. So I want to add an electron to both the elements. So I will add here one electron. I want to add here also one electron. In which case the nucleus will hold the incoming electron firmly. Think for a second and you can think the answer. So oxygen and tellurium, size we know. One is small size, one is big size. Electron has to be added. So in which case the nucleus can hold the electron very firmly. I think you have thought the answer. So I'll say the answer now. In case of oxygen. Why is it so? Because the size is small. Correct? The size is small. Nucleus is present here. It can hold the electrons. Force of attraction will be more here. In case of oxygen. Why? Because they are very near. One thing is small size of oxygen. Correct? Force of attraction will be more. They are very near to each other, the nucleus and the incoming electron. Think in this case what will happen? The size is big. Force of attraction is less. So here the electrons can be held very easily. But here the electrons cannot be held by the nucleus very easily. Okay, this point is clear. One more reason is there, we will check that also. So because of small size and force of attraction is more, the incoming electron can be easily held by the nucleus in case of oxygen. Compare this with sulfur now. Oxygen and sulfur. Sulfur little big size than oxygen. Correct? So here also electron has to be added. Same like tellurium only. Here it is difficult to add, here it is easy to add. But one more thing. What about the repulsion in the electrons? Already electrons are present. Right? Already the electrons are present in the orbits in case of oxygen. And it is a small size element, so the electron density is also more in case of oxygen. Correct? Small size means what? The electron density will be more because the electrons are very near to each other. Big size means the electrons are scattered here, there. So the density is less. And moreover we know this also, density is equal to mass by volume. Volume increases, density decreases, inversely proportional. So volume decreases, density increases. Correct? So what is happening? Electron density is more in case of oxygen. So repulsion is also more. Case of sulfur also repulsion will be there, correct, because there will be electrons in the orbits, so repulsion is there. So we write here that sulfur has more negative electron gain enthalpy than oxygen. Why it is negative? Because we are adding an electron, correct. The atom is accepting an electron, gaining an electron, so negative, and sulfur has more EGE than oxygen, and it is negative. So just make a note of this, all the points. So check the next one, multiple bond formation. Multiple bond formation means forming a double bond, triple bond. So the first element and the second element, they can form multiple bonds, correct. And as we move down the group, the formation of multiple bonds, the tendency to form the multiple bond decreases. So oxygen and sulfur, they can easily form multiple bonds, that is a double bond and a triple bond, with carbon, nitrogen, correct, even with hydrogen. So let's check how it is forming, because almost carbon small in size, nitrogen small in size, hydrogen small in size, sulfur, oxygen small in size, correct. So small size atoms, they can form the bonds very easily. Big and big, small and small. So let's check how they are forming. So carbon can form with oxygen, that we have seen in the organic chemistry. We will see, I will put up the videos for that also. So carbon, it can form a multiple bond with oxygen, double bond with oxygen in case of carbonyl compounds like aldehydes, ketones, correct. Hydrogen is there, that is S can attach with the hydrogen. I will write it as RSH, correct, RSH, where it is a thiol compound. Even it can form with carbon disulfide, CS2, carbon and sulfur, CS2, carbon disulfide, multiple bonds are present, right. So small atom, it can make bonds with small atoms, correct. So you can see here carbon with oxygen, RSH, carbon disulfide, okay. OH can form the bond, SCN, thiocyanate. So such compounds can be formed. The next topic, that is catenation. So compare with the oxygen and sulfur. Oxygen and sulfur, out of these two elements, sulfur has a tendency to form catenation, means it has a tendency to form bonds with itself, that is called as catenation. So it has a tendency to show catenation, but oxygen will not show catenation property. Why? Because oxygen, if they go on adding, the size is small, electron density is more, so what will happen? Electron repulsion is taking place. So because of that, oxygen bonds cannot be formed. So catenation is not possible in case of oxygen, but in sulfur it can form the bonds because repulsion is less, correct, repulsion is less because of the size. And even we can see that in sulfur S to S bonds are formed in hair. In hair also we can see sulfur to sulfur bonds. Oxygen to oxygen they cannot form because oxygen O2 itself, if we take the example, see the electron pairs are there, right, which will repel from each other. So check the last physical property, melting point and boiling point. So melting point depends on the van der Waals force of attraction, and boiling point always depends on the mass. Correct? This is always present, the van der Waals force of attraction. So down the group, in group number 16 elements, down the group what is happening? Force of attraction is also there. Van der Waals force of attraction is always there. Mass is also increasing, atomic number is increasing, protons, electrons increasing, atomic mass increasing. Therefore, MPBP, melting point and boiling point, is also high. Correct? So here we complete with the physical properties of group 16 elements. Hope you liked this video, understood the video, do the proper revision, watch my videos of P block, that is group number 15, which I have uploaded. Keep on revising, definitely you will understand the concept. Thank you all.